Welcome to our channel Circuits Analytica. In this video, we will discuss nodal analysis of a network with dependent sources. For the following network, employ nodal analysis to find V1 and I2. First step is to mark the nodes as P, Q, S, T and R as the reference node. Mark various currents associated with the nodes as I1, I2, I3, I4, I5 and I6. Look at this network carefully. Here, nodal voltages for node P, S and T are given. The only unknown nodal voltage is VQ. So we have to apply KCL at node Q. Applying KCL at node Q. There are four currents associated with node Q. I1, I2, I3 and 0.02 V1 are the four currents associated with node Q. Out of these, three currents are incoming. I1, I2 and 0.02 V1 are the incoming currents, while the lone outgoing current is I3. Therefore, according to KCL, we can write total incoming current is equal to total outgoing currents. So I3 is equal to I1 plus I2 plus 0.02 V1. So I2 is the current flow through 50 ohms resistance. I2 is equal to voltage drop across 50 ohms resistance divided by 50. Voltage drop across 50 ohms resistance is denoted as V3. Therefore, we can write I2 is equal to V3 divided by 50. I1 is the current flow through 45 ohms resistance. Current flow through a resistance is given as voltage drop across the resistance divided by resistance value according to Ohm's law. So voltage drop across 45 ohm resistance is equal to Vp minus Vq. Vp is equal to 5I2. Therefore, we can write current flow through 45 ohm resistance I1 is equal to 5I2 minus Vq, the whole divided by 45. Current flow through 30 ohms resistance is equal to voltage drop across 30 ohms resistance divided by 30. Voltage drop across 30 ohms resistance is equal to Vq minus Vs. Therefore, I3 is equal to Vq minus Vs, the whole divided by 30. And Vs is given as 100 volt. Apply KCL at node Q. We can write I3 is equal to I1 plus I2 plus 0.02 V1. So, we can write Vq minus Vs, the whole divided by 30 is equal to 5I2 minus Vq divided by 45 plus I2 plus 0.02 V1. So Vq minus Vs, the whole divided by 30 is equal to 5I2 minus Vq divided by 45 plus I2 plus 0.02 V1. And Vs is given as 100 volt. So therefore we can write Vq minus 100 the whole divided by 30 is equal to 5I2 minus Vq divided by 45 plus I2 plus 0.02 V1. Rearranging the terms, we can write 5I2 minus Vq the whole divided by 45 plus I2 plus 0.02 V1 minus inside bracket Vq minus 100 divided by 30 is equal to 0. So taking 45 into 30 as the LCM, we can write 30 into 5i2 minus VQ plus 45 into 30i2 plus 0.02 into 45 into 30 V1 minus 45 VQ plus 4500, the whole divided by 45 into 30 is equal to 0. Cross multiplying and rearranging the terms, we will get 150 I2 minus 30 VQ plus 1350 I2 plus 27 V1 minus 45 VQ is equal to minus 4500. 1500 I2 minus 75 VQ plus 27 V1 is equal to minus 4500. As I2 is equal to V3 divided by 50, we can write 27 V1 plus 30 V3 minus 75 VQ is equal to minus 4500, equation number 1. V1 is equal to Vt minus Vs. Vt is equal to 0.2 V3 and Vs is equal to 100. Therefore, we can write V1 is equal to 0.2 V3 minus 100. V3 is the voltage drop across 50 ohms resistance, which is equal to Vt minus Vq. So V3 is equal to 0.2 V3 minus Vq, as Vt is equal to 0.2 V3. So we can write V1 is equal to 0.2 V3 minus 100. So V1 minus 0.2 V3 plus 100 is equal to 0. So rearranging the terms, we can write V1 minus 0.2 V3 is equal to minus 100, equation number 2. V3 is equal to 0.2 V3 minus VQ. V3 minus inside bracket 0.2 V3 minus VQ is equal to 0. Opening the brackets, we will get V3 minus 0.2 V3 plus VQ is equal to 0. 0.8 V3 plus VQ is equal to 0. Equation number 3. So there are three unknown terms, V1, V3 and VQ. And we have three equations, 27 V1 plus 30 V3 minus 75 VQ is equal to minus 4500, equation number 1. V1 minus 0.2 V3 plus 0 VQ is equal to minus 100, equation number 2. 0 V1 plus 0.8 V3 plus VQ is equal to 0, equation number 3. The above three equations can be written in matrix form as matrix of 27, 30, minus 75, 1, minus 0.2, 0, 0, 0.81 into matrix of V1, V3, VQ is equal to matrix of minus 4500, minus 100, 0. So applying Cramer's rule, we can write V1 is equal to delta 1 by delta, V3 is equal to delta 2 by delta, and VQ is equal to delta 3 by delta, where delta is equal to determinant of 27, 30, minus 75, 1, minus 0.2, 0, 0, 0.81. Delta 1 is equal to determinant of minus 4500, 30, minus 75, minus 100, minus 0.2, 0, 0, 0.81. Delta 2 is equal to determinant of 27 minus 4500 minus 75, 1 minus 100, 0, 0, 0, 1. And finally, delta 3 is equal to determinant of 27, 30 minus 4500, 1 minus 0.2 minus 100, 0, 0.8, 0. So we will get delta is equal to minus 95.4, delta 1 is equal to 9900, delta 2 is equal to 1800, and delta 3 is equal to minus 1440. Therefore, we will get V1 is equal to minus 103.77 volt, V3 is equal to minus 18.86 volt, VQ is equal to 15.09 volt. So current flow through 50 ohms resistance I2 is equal to V3 divided by 50, that is equal to minus 18.86 divided by 50, that is equal to minus 377.2 milliampere. So here we are asked to find V1 and I2. So V1 is equal to minus 103.77 volt and I2 is equal to minus 377.2 milliampere. Thanks for watching Circuits Analytica. Enjoy learning.